literally a dude a lot already. Dr. Becker.
When we get to the end of this, you'll see that our ability to handle changing rooms is really critical. All right, so what you've seen about the talk so far, and I know this is way too many words for a slide, is we're going to walk through components that happen as we develop a brain. And I'm going to be adding in components about society during that time and the environment and other ways, nutrition at that time, to see how we can develop a human brain and what happens when we're developing this in an area of extreme stress, which in light of this topic, what we just went through is really minor stress. Keep that in mind. So when we're developing a nervous system, we start off at the very top. This is the first images that we have of a neural tube. So when you are way down in your mom's womb and we don't even really know you're here yet, weren't you cute? We basically start off with 3 areas which become forebrain, midbrain, and hindbrain. So here you don't actually quite look too much, but at growth you start looking like someone we would recognize. Now this is very crucial during this early part of development to make sure that these structures that you're going to use later on get laid down properly. One of the things that our body loves to do during this time to make sure we develop properly is during very, very sensitive times when the nervous system has to develop. That's when women get morning sickness. And morning sickness is actually keeping toxins out of her body so she doesn't affect the nervous system of the child in her body. Go morning sickness. All right, and as we're developing through to a brain that we can recognize that looks like closer to an adult brain, and then on into adulthood, I'm going to go through these steps of neural development because they're pretty critical. Those of you who've been in class know I'm not going to ask, but you've seen them before. So first off, we're going to make cells. Proliferation. Very critical. You're going to overdevelop the cells that you need. We actually build more. You have more brain cells before you're born than you do now. You didn't get dumber. You got refined. Okay, so we start off, we're developing the cells. They will migrate to particular regions, but just to give you an idea of the speed of the growth, you've got a neonate just born, 6 months and 2 years. That's the proliferation of cells and how thick it's getting at that point. So pretty critical because, like I said, you don't have as many cells as you did when you were born, because what you need to do is prune those back to the pathways that work and that work efficiently and that work well. So if you don't get enough extra built, when it comes time to prune the pathways, you only have what you have. So it's pretty critical to have this growth out to early on. And what also you're seeing, you said, wait, 2 years has more cells than when you're born, so what are you talking about? This is actually neural connections that have grown in, so cells connecting to cells. When we looked at Einstein's brain, he didn't have more cells than anyone else. He had more connections in a particular area. So it's all about the connections. Now, as we go into migration, it's hard to talk about things moving when they're not moving. So, back, we have neuromigration. We have some cells dyed in green that are actually reaching out their appendages and grabbing onto other cells. They catch a chemical signal from that cell and it either says stay here or go away. And so when you're building these migratory pathways, you get things like the cells that connect to your eyes meet in the middle, and then some of the pathways swap before they go back into your brain. So early in development, you're laying major pathways that you need to actually wire up your senses, to wire up different areas of the brain talking to each other so that you can work with different senses and different inputs. Once the cells get to where they need to go, they're not real neurons like we would notice. They actually divide off into different types. So you have what we call progenitors, cells that could become many other cells. Then we get into a neural phase where some of these branch off into all the different types of neurons that we have. We normally think of a neuron. There's a whole bunch of them. And then they branch off into what we call glial cells. Glial cells help us finish off our brain development. It's like if you had neurons without glial cells, you'd have a bunch of wires without insulation. Okay, any electrical folks out there? What happens with a bunch of wires without insulation? What happens to the signal? It dies out. It can't maintain the signal. So, as we're hitting the phase of this neural differentiation, yes, we're getting neuron cells, we're getting glial cells, but that's not happening all over the brain at once. That's starting in the brain stem and moving up into what we call higher areas for higher processing and thinking. So as one part of your brain is finishing off, say, your cerebellum, pretty well laid out by the time you're born, but you can't walk a tightrope yet, and that's for balance and coordination, because you have to wire that in with your body movements and what's going on there. So when your cerebellum is finishing off down here, your frontal cortex hasn't really begun to finish off its full differentiation. So we need the wire insulation to come in, the myelination. I love the images we have now because you can see across 2 weeks, 1 year, 2 years, as we're getting more and more of that white matter in there, that's the myelination. That's the fat that insulates your cells. One, it does work like insulation on a wire, but two, it feeds your cells. There are a lot of nutrients that those glial cells hold that allow your neurons to work more efficiently. One thing it stores, which is really critical for our happiness and ability to regulate our emotions, is serotonin. It stores up extra neurotransmitter serotonin. So if I say, I'm in teaching mode. If I say serotonin, what disorder do you think of? Depression. Yeah, so you need a good myelinated brain to be able to help balance your depression and anxiety. Now, this is really young. At 5, you don't have all that myelination gray matter you need. Look, at 20, there's still green spots on here. You're actually not done myelinating your brain until 40. Sorry, anybody over 40, your brain's done. But under 40, be careful. It's not done yet. But if you're over 40, we'll get to a little hint for you because there should be some takeaway messages besides the main message. So myelination starts early, starts in those lower areas, and then continues throughout most of your life. Okay, I warned I was going to hit this. So we have continued proliferation of cells. We have continued connections of cells. What we see in a 4-week-old human is not a lot going on up front. More density in the back. Get into a middle-aged human, you've got a lot of activity going on, and then, oh, neurodegeneration. Uh-oh. But for some people who I just looked out in the audience and was a little aghast at the neurodegeneration, what you have is efficient connections. Very efficient connections. Now, you go, but wait a minute. When someone asks me a question, I have to sit there and go, oh, I know the answer. I know the answer. Oh, Alzheimer's. No, it's not that you're losing your ability to think and reason. It's that you've got so much you know. It's a thick computer. It's a full hard drive. You've got to give it time. And that's why, and for the college students, please know this now for later. When you get older, play the wise card. Oh. It gives you time to remember that. And they think, oh, they're looking through all the iterations of what could happen. And no, you're just trying to find the one pathway. Do it. Doesn't it work? Oh man, they're so smart. They're thinking. Also, the things that I'm bringing up as ways to develop a brain are things you need to keep brains fresh, healthy, alive, able to learn, continuing to grow, because you can always make connections between your neurons. When you are 90, if you can still read, you can pick up a new language. It's going to take longer than when you were 2, but you can, because the brain's still active. So a long, long time ago, we had a misnomer about brains where if you had a bump on your brain, it was called phrenology, and that meant a special thing that was developing for you. No, that's not quite right. But if you don't use your muscles, you lose them. If you don't challenge your brain, it gets tired. So always, having to change a room, and oh my gosh, what does that mean for us? And that's good for your brain. Well, where do I sit now? We'll find it. Yeah. Also, as your brain is developing, you have different skills coming online. So yes, by birth, you're getting a big surge in sensory pathways. We know that you have to get exercise seeing things to be able to develop your eyes properly. You are not dealing in three-dimensional space, you won't be able to understand three-dimensional space. It's not just a wiring diagram that's set in your brain, it's interactions with your environment. Hearing things. A child who learns 2 languages as they're learning language can speak both of them with proper accent. A child that starts learning that language in their young age, say 10, will probably have their native accent bleeding into the other language. So all the college students who are like, I had to start Spanish 1 in college. Yeah, we kind of messed that up. But you can still learn it, right? Because you can learn it at 90. Yes. Language comes flooding in. This is where, if you can keep, if you have more than 1 language in the household, keep it going. It really does allow the child to learn. Now, they might come up with some mixtures of the 2 languages called trioles, but you can correct that and work for it. My grad advisor was from Colombia, and she was raising her daughter Spanish and English. They would speak Spanish in the house and English outside the house. Perfect lessons. You go to the grocery store, get me the rice. Go home, what's rice in Spanish? Yeah, do that. I just know English and neuroscience. So later on, your higher cognitive functioning is coming in. So as you're hitting young age, those neural pathways are developing into the frontal cortex, which is helping you with your higher order skills. Now, young children do not have a higher order skills, do they? Have you ever heard from a 4-year-old the storyline of Frozen? They what went? Timing and everything. Unless you know the movie, you have no idea what they're talking about. Right? because that's what we need our frontal cortex for. So as we age, that's coming online. As we age, we start to be able to use more and more of that cortex. We're able to put more things together, to blend them, to get out of things like functional fixedness. This is a pen. What else could it be? Well, it's scratch my hair. Not the other one, I've got ear infection. Okay, so what we end up with is as we're developing and these neurons are reaching out and they're making connections and they're seeing if they're going to be a viable connection or not so viable of a connection, we end up with two systems that start fighting each other. One comes on first. I have it listed second, of course, because that's how this came out, is your limbic system. You've probably heard this is your emotional system. This is what keeps us alive. This is what has allowed us to spread across the globe because it gives us memory. This purple area, you can't see it in the back, I know. It's called the hippocampus. And what's the way to remember hippocampus? It's in the word. If you see a hippopotamus on campus, you're going to remember you saw a hippopotamus on campus. Right next to it is the amygdala, and that's our area for rage and fear. That keeps us alive. If you walk up to a saber-toothed tiger and go, "Nice kitty," you should probably be afraid of it. And if you say "nice kitty," you probably won't live to pass on your genes. So, there are some things you are supposed to be afraid of. Great heights, you're supposed to be afraid of because you might not live if you fall off of that. I have that problem. I like great heights. So. Now, wait, that amygdala is a red ball. Right next to, if you see a hippo on campus, you remember it. We can remember our anger much easier than our happiness. Oh, that last argument? Oh, yeah, I got that one. The last time you really laughed out loud? Oh, yeah, what was that joke? I don't remember. Oh, we're so good at remembering that. Because when we're a child and we're crawling out on a spot and there's a glass floor, we don't know where the bottom is, and that scares us, and we go the other way and remember that that's a glass floor that we shouldn't trust. That helps us on a certain level of just basic survival. And the words under limbic system should not be problem solving and attention. It should be emotion, fear, memory, your basic emotions. Wow, I didn't fix that. Cool. So frontal cortex comes on later. That's your problem solving. That's so you can remember Frozen in the order it was shown. That's coming on middle life. It really starts to come in, in middle school when everything is black and white and yes and no and everything's so simple, and if you wear your clothes a certain way, then everyone will like you, and if you don't wear them a certain way, then you've got social problems. Think back to that clothing choice you had. Was it minuscule? Yeah. My pants are too short, they're flats. Who cares? But this frontal lobe, the point is it comes on later. You've already learned. I get scared of things and it helps me survive. Now you have to learn that difference and different things are okay. They're not going to hurt you. But my limbic system says they are. And now this newer area of your brain says they aren't. And so there's a lot of conflict that comes up in there. There's a lot of overriding reasoning. There's a lot of push yourself to do the presentation even though you think you're going to pass out from fear, because it will be okay. And once you realize it's okay, you can do it again. A little easier the next time. push yourself to do that, senior thesis, because it will happen and it'll be fine. Okay? Impulse control. The frontal lobe helps you control those amygdala responses that go, ah, I don't want to be here. Or your other impulses that say, oh, ice cream, I want some now. I'll eat the ice cream now and do my homework later. While my sugar crash is happening and then I can't focus. Oh, frontal lobe. So, there's a clash, right? You've learned that you react to your emotions and it keeps you safe. And now, here comes reason. So these are going to be fighting each other. Some of the fight comes through our stress response. Okay, Becker can't give a talk without stress response, right? Right. It is the core of everything. When you see something that scares you, your body goes through this series of hormone releases that tells your adrenal glands to release adrenaline, and the other part of your adrenal glands to release glucocorticoids. Glucocorticoids cause heart disease. Oh, but we like our stress response. It gives us such creativity when the paper is due the next morning and now it's midnight. Right? Right. So we get to rely on it. As a culture, we rely on our ability to turn up our stress response to get work done because we're addicted to Starbucks and all the other caffeine-related things to keep us up. If we're not up and happy, then something's wrong. So we have actually this hypothalamic pituitary adrenal, or HPA axis. That's going to give off glucocorticoids. Too much of that, I'm going to try to say it, atherosclerosis, which is not easy for me to say fast, which is hardening of the arteries, which is heart disease. Oh, but wait. I have this little SAM out here. Sympathetic nervous system to the adrenal medulla. That releases epinephrine, which is adrenaline, and norepinephrine. So, two systems, why? One responds more when you think that the problem is unsolvable. The other responds when you think it's achievable. Okay, do you ever have the coach where you go out there on the field and you got your score and the coach sees you after the game and says, I thought you could do more. Oh, thanks. You could do more? Oh. Well, that coach is starting you on the HPA axis. Oh, I'm scared. I've got to perform now for coach. I'm nervous. The SAM is the coach or the faculty member or whoever says, all right, this might be a little challenging, but I think you can do it. I think you got it in you. Just put your head into it, do your best, you got this. That doesn't lead to heart disease. That leads to less of a drain on your immune system. Okay, now I have a question for you. Some of you know the question is coming. When you're getting up to get ready for the day, and you're trying to find your keys, or your ID, or that paper that you just finished, and where is it? And you're having trouble finding it, or you're stuck in a traffic jam. What do you say to yourself? Or you're walking along the sidewalk, and you trip. What do you say to yourself? Yeah, you idiot! Okay, which kind of coach were you? Encouraging yourself or putting yourself down? Are you causing heart disease? So we do have choices on how we react to our environment and how we react to ourselves, which comes through that frontal cortex, which we have to learn how to use because it came on later, right? Thought this was about development. Yes, it is. Okay, So, we've got this huge pathway of developing a brain. We've got these systems that need to be built and come online, and then we have to learn how to override one with the other, unless you're really going to die from that situation, and then go with your basic one. But if you have adverse child experiences like living in a war zone, or maybe not a national war zone, but one in your house, it will disrupt your development, which will disrupt the development of that frontal cortex and your ability to override that limbic system, which will lead to emotional and cognitive impairments. You will read other people's signals as aggressive when they're not. You will see things as threatening when they're not. So then you get into risk behaviors, like one, you either avoid people, so you're not going to go to work because you have to avoid people, or you're going to find another way to get rid of that emotional pain, like alcohol, that works, or drugs, probably your suppressants, like your opiates, that help you relax, because you don't have the wiring and the programming to relax on your own. Can lead to other diseases. Remember the HPA axis, when you have that triggered, you're on your way to hardening of the arteries. Also, when you trigger that too much, you're on your way to diabetes, because your blood sugar gets tricked. I'm smiling, but I don't mean to be smiling. You also dial down your immune system, which doesn't allow you to attack cancers. Stress doesn't cause cancers, but stress doesn't allow your body to be able to defend from cancer. So, wow, any other diseases I can come up with? Oh, great! You burn out your hippocampus when you stress too much. All the college students are going, wait. I'm in college, I'm stressed, and I'm burning out the area of the brain I need to memorize. Yeah, good, go college. So, how do you deal with the next threat that's coming, the next thing that's new? Sound, not HPA. It's okay. You can do it. So, any evidence of this? Yeah. You heard of the Romanian Orphanage that we've studied a lot. Lots of children, not a lot of help, not a lot of children picked up, cuddled, taken care of the way kids need to. Here's an adult. Left brain, normal brain, right brain. Those big black areas are where that limbic system should be firing in and helping with the auditory system so you can understand verbal as threat or non-threat. And the very top where it's green and yellow and should be red, that's the frontal cortex. That's the reasoning skills. And that's just kids who weren't picked up enough and changed when they need to be changed and fed when they need to be fed and allowed to go out and play. It really does alter the brain. Even things like being held or snuggled. There are things about us needing touch that really helps us develop our brains. Okay, so this is really depressing. If you have, let's see, an environmental characteristic of a poor home or lack of home, no health care, no healthy food, or rare food, no green recreational space, and exposure to violence, then you end up with not only, trouble actually getting born or getting here, but while here, having trouble growing up. There is stress-induced dwarfism, and I think we call it stress-induced small stature, because we're nicer about the name. Where the body is spending its time burning up the energy with stress and not catching the growth spurts, missing growth spurts because of it. On top of that, it's poor nutrition. What might be helping when you don't have the frontal cortex that can do that? Hypertension, high blood pressure comes with high stress response. You're always increasing your body's energy. You're increasing your blood pressure, and it gets stuck there, in a sense. So it's compounded by lack of educational services. So if you are developmentally delayed in some sort of reading or writing skill, and you're not getting exposure to reading and writing, which leads to lower income, which passes on to the next generation. Also, there are factors of if the person raising the child, okay, there's always a moment or two when you're raising a child and you just kind of lose it. But for the most part, you're giving the child comfort and assurance that you're there and stability. If you don't have if you're the parent and you don't have the emotional stability, then you can't give that to the child, and the child's not learning that emotional stability. If the parent is one that's dealing with their emotions through drug and alcohol use, the child's getting no exposure to how to deal with their emotions, so they are more prone to drug and alcohol use because that's what they saw, and they didn't know any different. So it cycles back around and could cycle for many generations. So the perfect storm, right? You have an environment that is socially torn and physically poor, which leads to a biology that's not developing the way it needs to, which leads to a brain that's not able to process and handle things the way it needs to, which feeds back into. So what do we need? How do we make it better? There are just, some of these phrases are going to just look silly. We need sleep. It's time for sleep. You need consistent and undisrupted sleep. Back when there was this little bombing of a place called Baghdad that was happening every night, what they were doing was basically making everyone post-traumatic stress because throughout the night they were not getting sleep. So people are like, what do you think of the war? And I'm like, okay, neurologically bad. Okay. Educational resources, not just to feed the brain and give the brain that stimulation it needs to develop properly, but maybe catch things that may be growing a little slower. Daily exercise, doesn't that sound like your health class from way back when? We need to interact with our bodies, and our muscles need to interact so they can grow, so our brain can get an idea of where our muscles are, so that we can manipulate objects and do things. We need to be active. Oh, being active on a Wii does not count. Active like go run around active, not like move your wrist active. Hey. A consistent place to call your own. Maybe not your own room, but your own home base, your own safe space, where you can sleep undisrupted. It's not happening in this case. Constant nutrition, consistent and good nutrition. It's not happening. Emotional support. If you have people whose parents are now gone, or maybe they haven't passed on but they're missing, or the child has gone missing, that's not good, consistent emotional support. So what we see on this list, and I do want to spend a little time on exploring your environment, because what do you learn when you're a kid out in the yard with a stick? How many things you can do with a stick, which allows you to solve problems later on. You learn about physics and levers and trajectories. Oh, that's pretty critical. not just playing baseball to make the team, but it's just playing to understand your world, your physics. So hopefully we can get to some spot where this is capable, so we can have the stimulus we need, the nutrients we need, the environment we need to grow better brains. What we're seeing is, because of that, anxiety, depression, attention deficit, post-traumatic stress, and things that could last throughout their life. That's all I got. Questions?